Okay, so this is lesson 2 of the 2 lessons where I can unfortunately not be at school to teach you. Hopefully the last lesson went really well. The video was all that you needed, combined with worked examples and each other in class and all that sort of thing. Unfortunately, I don't really have the opportunity to wait for feedback from that to change anything for this one, so I'm just making this video right after I did the last one, and as such there won't be too many changes. This will be the last lesson of Trig, pretty much. We'll do one sort of overview review thing when I get back, just to see where everyone's at and how they went. But at the same time, that also means that I have a dreading feeling that there have been a few people in class who have not been following up the work set in class and getting it done for homework. So this is my little push and my little reminder to those people that you do need to be up to date with your classwork, because we are pushing along. As you can see, not even me being away from school will stop us from doing work. So we really need to be on top of everything that we're doing, so that by the time our topic tests and our assessments kick around, which is only a couple of weeks away as well, that we're all ready for them. Okay, so kicking into this lesson, as it says there on the screen, this is a part of this little section here is a review of prelim general stuff, where we had these field diagrams, or field survey diagrams, or field notebook notation thing. I don't know, they had a whole bunch of different names, but they really had field in them, because what they meant is some person went to a field and they needed to take the measurements of that field. So they pretty much just picked one corner and they walked in a dead straight line to a corner opposite that one. So down here you can see that they started at point D, and point D is 0 meters from point D. They haven't moved. And then they walked forward 16 meters in a straight line. And once they got to that 16 meter mark, they turned to their right, looked out, and they saw another corner of the field that they're standing in. And that corner was 26 meters away. So that's what that meant. And then they continued walking on. Now, this 30 is cumulative from point D. So it means they're 30 meters from where they started, and they're only 14 meters away from where that H corner is. So once they got to 13 meters away from the start, they turned to their left and they saw that there was another corner, 28 meters away. They continued walking on until they got to another corner where they turned, looked to their left and found another one, and then they continued walking 68 meters from when they started, and they got to the final corner of the field. Now what this looks like in terms of an actual picture is too far. My bad. That there. So you can see that they started at point D, they walked 16 meters up, turned to their right, and they saw corner H 26 meters away. Now you'll remember that in the field survey that they walked to the point 30. So that means that there is only a distance of 14 between point C and B. And then they looked to their left and they saw corner E 28 meters away. They continued on for a whole bunch, 27 meters. They looked out to their left, they saw corner F, and then they continued on for 68 meters in total, but that 68 is now divided up between an 11, a 27, a 14, and a 16. All those corners are labelled. Now that centre line, the one that I drew in red, is called the traverse, because that's how they traversed the field or travelled. And each of the lines coming off to the corners are called offsets, because they are branches and an offset of the main diagram, or the main traversal. So that's pretty much prelim stuff, and what we will be looking at is slight variations on these. One will be a plane table diagram and the other one will be a compass diagram. And they all are measuring the sizes of fields or plots of land, essentially. That's pretty much what we're looking at here. Okay, so we're going to be looking at the first one that I mentioned was the plane table radial survey. I'll try not to read that, but it does explain what I need to say pretty well. So a plane table survey is done by, if you imagine standing in the middle of a field, having a chair and table, putting it right in the middle, or as close to the middle as you can be bothered to find, putting a piece of paper on that table and looking around you and drawing on that piece of paper where the corners of the field are, how far away they are in terms of meters, and how many degrees, or what the angle is, to turn from one corner to the other. That's pretty much what it says there. So here's some diagrams to help us out. So that first one there, hopefully the table's not to scale, otherwise that is a massive table. They've put it right in the middle of the field, and they've labelled themselves at point S. And you're sitting facing the table as you are on the screen. You look up and you see point W is a corner. So you draw a line from point W. And then you turn to your right, you keep turning to your right, and then you see another corner. Alright, that's point X. You flip around, look behind you, there's another corner, that's point Y, and you look to your left and there's point Z. Once you've got that drawing, you've then gone off and measured how far away those corners are and how many degrees it took you to turn from one corner to the other. And that's where the second diagram comes from. So from your point S, the corner W is 92 meters away, and the angle between when you're staring at W, turning to your right to look at X, is 112 degrees from there to there. Once you've got point X, you measured that, and then from point X, you only needed to turn 47 degrees to then see point Y, which was behind the original way you were facing. From there, you only had to turn 96 degrees to then look at point Z, and lastly from point Z to point W, that was 105 degrees. Always worth noting that this is a full circle, so if you add all those numbers together, you should end up at 360 degrees. Alright, so these kind of questions, they're going to be given to you with the plane table radial survey diagram, get that in ya, given to you much like that second diagram there, and there are going to be a couple of questions which could be asked. Now, they're pretty repetitive, they're nothing new that we haven't done before, so I've just put the working out on here because it's just a waste of time to do it over and over again. It's kind of like these cooking shows where here's one I prepared earlier. So what we've got here, now this information can be used to calculate the perimeter. So going back to our diagram, remember that the perimeter is the distance around the edges. So we're going from here, actually I might get rid of that and use the colours that I've done for the angles. So this is green, the next one's red, and then I had, yeah, black's going to work well, let's do that, and the last one was blue. Okay, so the perimeter is all four of those distances added together. Heading to our working out, they see that the first one they're working out is side WZ. Now WZ is the blue one. So I'll put a little bit of blue next to this. Okay. The information given to us in these questions are, we're given the two side lengths it takes from get to the middle of the field to each of the corners that make it up, and we're given the angle between them, and we're asked to work out the length of the actual fence. So you can see here, hopefully with my mouse, that we are given the 92 meters, we're given the 104 meters, and we're given 105 degrees, and we're asked to work out this length. So 105 degrees means we do not have a right angle triangle, so we are either using sine or cos rule to do this. Sine rule, you need two angles and two side lengths. We have three side lengths and one angle, which means we're using the cos rule. And that's why it's repetitive, because there is the first example of the cos rule. Plug all those values in, work out the distance. So that is only the distance from W to Z. You then need to do the cos rule again for black, the cos rule again for red, and the cos rule again for green. Add all four of those answers together, and that will get you the total perimeter. Much like you see here. There is all the working out, and at the end of the page, you can see the four answers, or the four side lengths, are all added together to get you the total perimeter of that shape. I don't feel like I need to go through that. It is the cos rule. After last lesson and the cos rule lesson itself, this will now be the third lesson we spend on using it. So I'm pretty confident that everyone will be able to do that. And with just the diagram explained, you're now ready to go. All right, the second kind of radial survey that we are given is the compass one. Now, there's not much of a difference between compass and the plane table. except that plane tables are really easier to work with because the angles that you would naturally use to work things out, using either sine, cosine, or the area rule, are given to you straight away. Whereas a compass one, as the name suggests, relies on the fact that you use compass bearings, or the degrees of a full circle between 0 and 360, from pointing north to give you the angles in each of the triangles. So there's a little bit of working out that needs to be done. I'll start with this red angle here. So you can see that at point J, you are 86 degrees around from north, and at point K, you are 165 degrees away from pointing north. So naturally, the angle between them is just the difference between those two numbers. So 165 minus 86 gives you 79 degrees in that little bit there. The difference, or the angle, between K and H is just those two angles minus from each other, finding the difference between them. So that gives you 118 degrees. Picking another colour. The angle in here is given from those two angles minus from each other. So 340 minus 283 gives you 57. And the last one is the trickiest one, or possibly the first one, depending on how you're going to work it out. So all angles are taken from being at the north point. And you can see that this triangle does not exactly match up to being north. So there is this point where at north, you're also at 360 degrees, which means that in here, at this angle, there's 20 degrees. Takes you 360 to get all the way to north, minus the 340 as to where the eye is, leaves you with 20 degrees in there. And this one is the 86 straight up that is given to you. So in terms of, I'll try and make this as easy to see in black as possible. In terms of the full angle inside this triangle, it is the 86 plus the 20. So in there is 106 degrees. Now what I suggest each and every one of you doing is, once you've worked out all the angles that you need, add them all together and make sure that you hit 360. It's just one little check that you can do in an exam that will not take very long and ensures that you get the mark for that question. Adding those four numbers together, 106, 79, 118 and 57, I get 360. I got my calculator here just to make sure that I am correct. So that's how we do it. On the next slide is pretty much those calculations there. And they are asking for the area. So by working out these angles, and if we were to work out the area of these triangles, we would need how high they are from the base length or from a side length or all sorts of things, which is just too hard to do. But thankfully, and remembering back to one of our lessons, we do have a formula that uses side lengths of triangles and the angle between them to work out the area. And it involves using sine. So remember, your area of a triangle formula is a half of AB multiplied by sine of C. Now remembering that angles and side lengths are opposite each other, so if we have a triangle like this one, where we've got A, B and side C and angle C need to be opposite each other. So to be able to use this area of a triangle rule, A and B need to be the side lengths making angle C. That's pretty much what you need. And in terms of our diagram, that's pretty much what we've got. So you can see side length 87 and 91 make up the 79 degrees in the middle. Side length 91 and 84 make up the 118 degrees in the middle. 78, 84 make the 57, and the 78 and the 87 make up the 106. So back to the old repeated calculations there. remembering to use the letters to describe the triangles you're talking about. So this one here says triangle IOH. So triangle I to O to H. So they're working out the area of that triangle there. Using the vertices or the labels of the letters in each of the corners makes your referencing very, very accurate and very, very easy to read. So I suggest everyone get in the habit of doing that. It's something that you learned about in about year 9 onwards. Okay, once you work out that for all 4 triangles, add your answers together and you get the total area of that field using the compass radial diagram. Other than that, that's pretty much it. So there's only 2 types of diagrams that we're looking at. The plane table one, which is the easiest one to work with because all the measurements you need are given to you straight away. And the compass one, where the angles are based on bearings of a compass and not the actual ones of the triangle, and you need to do as I've done just there and minus each of them from each other to calculate the angle you need, remembering not to get stuck at the north point. So that one actually became an addition one where I had to add the 20 degrees in here onto the 86 in the triangle to the right. Other than that, I'm all done. Much shorter video this time, much easier work. Make sure you log on to Schoology, pull up the worksheet or the file PDF for today's lesson. I think we're up to lesson 8, and radial survey diagrams will be the topic and the heading and the file name of that document. Picking up your level 1, 2 or 3, whatever one you feel comfortable with. Hopefully no one's really doing level 1 with this. It's pretty straightforward and pretty simple, so I'd be keen to see people doing level 2 and 3. Thanks very much for your time in watching this. Good luck with the work, and I look forward to seeing you all on Wednesday.